What's up guys, welcome to the 12th tutorial in our Python language basics. This is on the next collection type, dictionaries. Dictionaries are my personal favorite just because they're the most interesting, they have more going on, and I find them very useful in unique situations where lists just don't quite cut it. So let's go over what we'll cover. We're just going to start by creating some dictionaries, then we'll talk about how to access and modify dictionary elements, and then just like before, we'll go over some common dictionary operations. Now dictionaries are a little more complex, there are lots of operations. We'll again just cover the more basic ones, the ones that we'll find ourselves using more often. If you want to learn more afterwards, then turn to the docs. So let's head on over to the code. First things first, get yourself a new cell started. We'll be writing the code within the cell. We'll probably have to take a couple cells to do so. Okay, so before we get started, let's talk about what we're going to be doing here. So the first thing to note when using a dictionary versus just a list is that the dictionary is based on key value pairs rather than just indexes and values. Okay, so with a list, the index or the position of these items is important. Okay, if I need to retrieve an item from my list, I need to know its index. So I can use methods to help me find the index of it, and then I can retrieve it through that. Okay, but the position is very important. If I shuffle these, then it becomes an entirely different list. However, with dictionaries, the position or the order really doesn't matter. It doesn't matter if the item I'm looking for is at the front, the back, or somewhere in the middle. What's more interesting to me is under what key that value is stored. So rather than storing items at positions or indices, we store them at keys. Now we can also use the keys as other values. For example, what we're going to do is build up an inventory. Well, in our inventory, I know we've already done this a few times, but this one will be a little more comprehensive. We'll have items, and then we'll have the quantities of those items together. So kind of like with this tuple, we have the name and the quantity. That's what we're aiming to build, but lots of these instead of just the one. Okay. So I guess what we can do is go ahead and get started, and then that'll be a bit more easier to understand where we're coming from. So we'll create an inventory. It's a good thing types are flexible in Python. And within this, we're going to, within these curly brackets, so this makes a dictionary, we're going to put our key and value pairs. So the keys and values can be of any type we want. We can have, for example, integer keys and string values. We can have Boolean keys and integer values. We can have string keys and integer values again. It really doesn't matter as long as they're consistent. So we would have all string keys or all int values. Otherwise, things get a bit confusing. So in our case, we'll have the string names and then the int values. Okay? So this makes sense because each of the quantities of the items will be stored under the name. So let's just enter some random items. I'm just going to populate with some stuff. So we'll have a knife 1, we'll have a few health kits. Let's have 3 of those. We can have, I don't know, some wood or something, pieces of wood, and we'll have 5 of those. Okay, so let's talk about the setup here. Again, curly brackets to indicate that we're dealing with a dictionary rather than a list. Each of the elements is this kind of key value pair separated by the colon. So that's how we know it's a key value pair. And separated by the commas again. So whereas before, each of the list items, even if it was a whole list, is considered an element like this, okay, or just a single value like this. In a dictionary rather, this is considered one element of the array, this key and value pairing. All right. Now, even though there are technically 2 values at each index, there's both the key and then the value associated with it, we're going to consider these as the values, okay, and these as the keys. So they're kind of 2 separate entities. When I talk about dictionary values, what I really mean is these guys here, not necessarily the keys. All right, so that begs a question, how do we access these items then? If it's not index-based, if the order doesn't matter, then how do we get the values stored in this dictionary? Well, there are lots of ways. First of all, we can use square brackets just like before, except that instead of entering an index, we enter the key, and that will retrieve us the value stored of that key. We can use a get function. We'll explore that a little bit later on. Or you can get all of the list, get a list of all of the keys and all of the values and go from there. So we'll kind of explore a few of those. The first and perhaps the easiest one is just using the square brackets. Let's say I want this value here. I do my inventory and I get the value stored at this key of knife. Okay, I can go ahead and print that out if I want. If I run that, it'll just print out 1. Same with if I printed out health kit. Okay, should be capitalized. Case does matter. Okay, we get 3 and so on and so forth. So essentially, I'm entering my key and I'm retrieving the value. So this is very similar to just entering an index and retrieving whatever value is at that index, but in this case, it's key associated, not position. Okay, cool stuff. So that also goes for modification. Now, let's say I wanted to, actually, I guess we'll cover 2 things first. One, inserting elements, and the second, modifying elements. So let's say I want to modify, I picked up another knife, so I want to modify whatever value is stored at knife. So now I'm going to set it to 2. Okay, let's print out my inventory. Cool, so we'll go ahead and run that. You can see that we've now reset that value there to 2. Realistically, what we would do is like plus equals 1 or something, but you know, that's different. So we've set the value to be something different. Okay. Alternatively, what if that value, if this key value pair doesn't exist? Okay, we could use like an insert function, but there actually isn't really an insert function for a dictionary. That's because it's not needed. Instead, what we can do is just say inventory of some other key. So let's say we acquired some gold. We acquired 50 gold. What we do is inventory of gold is equal to 50. And don't worry, this will run, even though that key doesn't yet exist. Because if the key doesn't exist, then it creates a new key value pair based on whatever value we associate, and then inserts it at the end. So if we once again print out inventory, I'm just going to copy and paste that, then we should see that we have gold and 50 added to the end. So using this technique, if the key exists, it replaces the value. If the key does not exist, it creates a new key value pair and then inserts that at the end of the dictionary. Now, there is no insert method or insert function, for those of you who don't really know object-oriented programming, because the order really doesn't matter. It doesn't matter if I stick my new key value pair on the end, or at the beginning, or in the middle, because the order is completely irrelevant. Okay? Instead, what we're interested in is, again, that key value pairing. Okay, so we've seen how to retrieve, how to modify. What about some of the different functions that are involved in these dictionaries? Well, for that, I'm actually going to go ahead and start a new cell. Yeah, we'll do that. I'm going to copy over this original inventory just so that we kind of get it resetting every time and don't get the weird state change issues. Okay, so I guess I'll start by talking about the get function. Okay, and that's if we're trying to retrieve a value for a key that doesn't exist. So let's say I forgot that I didn't add gold to this one, and I'm trying to get whatever inventory of gold is. Okay, and I'm going to print it. Basically, I just want to see how much gold I have in my inventory. Okay, well this right away is giving me an error, which is annoying. This would crash your program, saying we don't know what gold is. There's nothing in this dictionary called gold, and so we can't fetch it. So that's a big problem, because I don't necessarily know, I mean, here I do, but in my actual game, I might not necessarily know whether or not I have gold in my inventory. Okay, so the easier way to check this is to use the get function. So instead of doing this, because this is going to cause our program to crash, what we can do is do inventory.get, okay, and then enter the key that we want, and this I'm going to print out. Okay, so go ahead and run that. So instead of my program crashing, I get none. Now this makes sense, because again, there is no value associated with this key, because this key is not a part of our inventory. So this function definitely is more flexible, it's more useful than just doing things this way. This is kind of the quick, easy way, but I would recommend, where possible, to use your get function instead, because instead of your program crashing, you get none, and then what you would do is check to see if that is equal to none. If it is, then we don't have any gold. All right. Now, the alternative way would be to get a list of all of the keys and check to see if gold is in that. So that's easy to do as well. What we can do is select our dictionary name, so inventory. We can spell it properly. So inventory, and we can just get the keys. Okay, so let's just go ahead and print that out. And same with the values, actually. Might as well do it at the same time. Values like so. Okay, so this now returns me a list. It's actually technically an iterable type element, but we can kind of treat it like a list of all of the keys. So knife, health kit, and wood. And then the values 1, 3, and 5. Okay, so if for whatever reason this didn't exist, what I would do is I would get my keys. I would search through keys using probably a loop and say, are any of the keys equal to gold? If they are, then I want the value. And if we get to the end of the loop, if we get to the end of the list and there are no keys, no values associated with that key, then I know it doesn't exist. Okay? So we've seen how to modify, how to add or insert, but what about removal? Okay, so for removal, we can use a pop function. But it's not quite like the list pop function, because remember the list pop function just takes the last element off the end of the list. For a dictionary, we have to enter the key, and then it removes that key value pair. So what I would do is I would say inventory.pop, and then the key, so in this case maybe we'll pop the knife off, dropped it, or something bad happened, and then we'll just go ahead and print out our inventory. Oops. Wow, really not spelling that properly. Okay, and then we'll go ahead and run that. Okay, and this is going to basically get rid of knife, not only the key, but also the value associated with it, because otherwise, if there's no value with the key, then it essentially disappears. And then you can see that it's given me the updated inventory. Interestingly enough, this pop function actually also returns knife, so we can actually print out the result there. That should return us a tuple with the knife and then the value. Actually, I guess just returns the value. In this case, it is 1, which makes sense. Okay, there was a 1 associated with this key. I guess we don't even need the tuple because we know what the key is anyway. We can put that in a tuple if we want, and so on and so forth. Also, if we want to clear the thing out, we can call upon the inventory.clear function. Like this, it's going to be our dictionary.clear, and that gets rid of everything. So basically, just clears out our inventory just like before. Also, we can get stuff like the length. Okay, we can get the max, and we can get the min as well, just like with our list. So we can get the min of inventory. I'm actually not going to clear it because we want to be able to actually get these. So I want the length of my inventory. Okay, I also want the min of my inventory, and then the max of the inventory as well. Okay, so these actually do work. Oh, actually, I should probably be printing these out. Let's do that, print and print. Okay, and we'll just close off the brackets there. Okay, there we go. So the length is 2. If you remember, we actually removed something, so this is what the inventory looks like. Makes sense that there are 2. The minimum of our inventory is health kit and the maximum is wood. So interestingly enough, guessing the minimum and maximum actually does so based on the keys and not the values. Okay? Or rather, it does so based on the value associated with the key and not that. So this is kind of hard to demonstrate because this is also smaller in alphabet as well. So it could have been that. So let's actually go ahead and add something to inventory. And do inventory, and we're going to say, just to demonstrate this point, we'll do maybe apple. Okay, and we'll have 10 apples. Okay. Oh, that should be... Apple is equal to 10, like that. Okay. So we'll go ahead and run that. And this time the minimum is apple, all right? So because the apple key is the least value when it comes to our keys, then it's going to, we're basically going to return that instead of the health kit in this case. Alright, so that pretty much covers the basics of dictionaries. Like I said, there are more functions to explore. I would definitely recommend you check them out. Dictionaries are very, very useful they kind of help us avoid long if statements, and especially if we don't really care about the order of items, but we want to know exactly what key they're stored under, dictionaries are going to be your friend in that regard. Now, we only have one more collection type to cover. Those will be ranges. Those are really, really straightforward, so this next section is going to be quite short. So stick around for that. Thanks for watching, and we'll see you guys in the next one.